here is the training for the cooldown 102. This is the physical data taking training for the action detection. So first, let's take a look on the measurement and control program, and also what's the experimental setup we used in current cooldown. So here is the folder, and here is the path of this folder, including all the control program you will use for the data taking. So including the switch to VNA, move the motor, rotator motors, and S22 measurement, and switch it back to the signal analyzer, and also the action measurement with this new signal analyzer. So this is our experience setup for current cooldown. Basically, when we do the data taking experience, what we will need to use is only depends on two measurements. One is S22 measurement, which is you need to work with this VNA here, and another is the signal analyzer, including in this PXIe module that it provides the signal analyzer here. And once you do the data taking, which means you switch it to the signal analyzer, so you do the data taking from this line, the signal from here all the way to the signal analyzer. Okay, so still let's get a quick check on the instruments you will use in the whole experience step, just including 5 experimental steps. And still, don't worry, that's still very easy. So just take a deep breath and just treat it as a work. So you take a look on the checklist and make sure what's the step number. So in this time, only a step number you are going to operate. And just pay attention on the resonant frequency of the previous operation, and just keep it in mind. So later on, when you switch to VNA and tune the motor, you will get your own resonant frequency for the current operation. So you also need to remember that numbers, because you will need to use that. If it's possible, then trying to write some logbook to make it easily to tracking back what the operation is. Let me quickly show the checklist I wrote here. Because right now we are getting a very good intrinsic quality factor of the cavity, so we only have the step in here. The step means let's have its own resonant frequency. So in next step, use the rotator motor, you will change the resonant frequency of the cavity. The shift taker will need to record, of course, your name, the position of the rotator motor, the performance of the cavity, K01, K2 resonant frequencies, and also the beta volume. If that's necessary, then you guys will need to record the T6 and the data taking time. So first, still use this program to switch the real line to the VNA. Okay, so just by clicking these wrong buttons, and you'll hear a click sound, and you change the real line to the VNA. And also the input line will switch to VNA. With that program, you will make your input from this line and the output from this line. So you are ready to go to doing the S22 measurement by clicking this wrong buttons and switch the real line and input line to the VNA. Then after that, you need to ask the motor to drive the rotator motor to move the rod. So right now, I still mark the unknown number here. First of all, you will know how many pulses you need to inject in first move rod. Then after that, if you need to fine tune the resonant frequency, remember just change this number to 1 and fine tuning the resonant frequency pulse by pulse. Okay, I will mention more clearly for the later process. So remember that this is the how many pulses you will inject to the motor. The forward means you make the motor rotate forward, which will make your resonant frequency become larger, and backward will make the resonant frequency smaller. Next thing is basically you ask this program to help you do a S22 measurement by clicking this wrong button. One thing you need to remember is that based on your checklist, what's the step number you are going to operate? Remember to change this step number here, okay? Because this is related on where the file will upload it to now. So remember, change this step number to the number you are going to operate in current step, okay? So change the step number you are going to operate, and then click the button to let this program help you to do the S22 measurement and also the fitting. Make sure that this data value close to 2. Tomorrow we'll know what the range will be, but basically hope that this can handle very close to 2. And also compare the resonant frequency to the previous step number. So if your resonant frequency is in some certain range larger than the previous resonant frequency, then everything is okay, just record it on the checklist. We will determine this range after the DR reach to the best temperature and we do a very quick check. So I still left the unknown number here, but I will fill it after we know what the number is. So in here, your resonant frequency is not in the proper range, then how you should do? You just go back to step 2. It's a moving rod process. So change the pulse number to 1. In this case, we chose the strategy that we fine-tuning the resonant frequency of the cavity pulse by pulse. Fine-tuning your resonant frequency back to this range larger than the previous one. Then that means you already finished the fine-tuning of the cavity and everything is good. Just record it on the checklist and you can go to the next step. Okay, just click the run buttons and switch the real line to the signal analyzer. After that, this part is the different part. Right now, this is the program front panel of the data taking process. It looks very complicated. Basically, the things you need to work with is just this half of this part. Okay, so this is the power spectrum of your current data taking, and this is the power tracking minutes by minutes. So after 1 minute, you'll get 1 point. After 1 minute, you'll get 1 point. When you go into the data taking part, what you need to do is like this. Make sure it's how long. This is mean exactly how long the data you're going to save to the NOS. The span, basically this is about the data taking frequency of the signal analyzer. We'll fix it to 2 MHz, so you also don't need to change this number. And this step number exactly as same as the step number here will also exactly the step number here. So remember your operation step number and remember change it at here, also at here. Okay, after you get your S22 and fine tuning, you will know what's the resonant frequency of the cavity. So you also need to change your center frequency of the signal analyzer equal to the resonant frequency of the cavity. So remember to change this number. After all of this, just click this save with a question mark buttons, and you will see this button will lines up and lines off. And after that, this line will lines up. This is how this program works. That you click this will lines up and lines off. Then you will see this lines up, means the data both taking and saving to the NOS. Let me go through this word I write in here, but basically this is the idea I just mentioned. Change the step number you are going to operate, and change in the center frequency, which need to equal to the resonant frequency you just get from the VNA observation. So, and also notice the unit, because somehow very trivial, very tricky is that the unit on the VNA I write it in hertz, but in here the unit is gigahertz, like this G here. So remember the unit, because the frequency resolution of the signal analyzer is down to 1 kilohertz. So down to the digit behind the point with 6 digits. This will down to the 1 kilohertz. Make sure the how long is 20, but still you see I mark with the blue color, means we still need to check with what's the real performance of the cavity. But right now I write in 20, as somehow we predict this is the optimized numbers we'll get. 20 minutes real data taking time. Once again, confirm your step number and the center frequency is correct. This set buttons. Okay, it will lines up and lines off. Then you will see this button lines up, means the data right now is uploaded to NOS. And basically that's all. Once the data already taken for 20 minutes, you will see this line turns off. You will see this line turns off, means the saving is done. So basically, you finish one step, and that's it. And for the convenience, for the shift taker, I also marking some. Sorry, it's not quite clear, but this is what I write in here is the current scan number and total scan number, and also this time per loop. So what these 3 parameters mean is that one scan number is corresponding to 1 second real data taking. 20 minutes means 1,800 scan number. So once you running in this situation, you will see this will start increasing from 1, 2, 3, etc. Once the number is equal to this total scan number, then this set button will light off, and you can roughly predict how long will this program running in this way. Okay, so basically that's it. So basically Okay.